Hello everyone, I'm Nicola Carboni and I'm here to present you the Semantic Reference Data Integration Initiative, part of the work done by the Swiss Research Infrastructure, better known as SARI. The work on semantic reference data has been developed in order to answer a quite simple question, which is how we can facilitate the exchange, reuse, and integration of knowledge in the domain of digital humanities and art history. Our solution to the question is to find methods and tools to better integrate our resource and knowledge together. Methods that allow us to exchange information at a multifaceted community. However, the problem of integration is not that easy to solve. Many domains have developed their own solution, creating information structure to be followed in order to make the data compatible or at least researchable. All of us most probably have seen the rise of at least one new standard to be followed. And if we look at a simple facet of a domain, the description of a person, for example, we can see, however, that when we talk about standard, we are talking about multiple standards and not a single one. The consolidation of such diverse sources together can lead to failure of integration and retrieval. The data could even appear to be there, but finding them would be an extremely difficult operation. An elegant solution to the problem is to translate the data into a common shared information structure, able to characterize the diverse nuances of the recorded information. The solution envisages the use of an ontology for data integration, and within the cultural heritage domain, SADOC-CRM has been used as a standard ontology for integration of diverse datasets and has proven itself to be robust, reliable, and able to take into account the dynamicity of the data recorded by the community. It's important to state that ontology in respect to traditional knowledge organization systems such as the SARI or vocabulary provide better tools for integration and enable a plurality of view. And also they are logic grounded, can be used for computational reasoning. However, they require specialized knowledge. We do believe that the reason for the lack of adoption and wrongful adoption lies exactly in this complexity. In order to provide way to universalize their use by different institutions, we developed the semantic reference data models. The developed model takes on the problem of ontological complexity, defining and making evident for an entity we want to document its connection with other information. Given two entities or piece of information we want to express, we determine a chain of property and classes, which are the main building block of an ontology. Then, taking into account the constraint of the ontology, we reflect the meaning we initially determined. This is a conceptual exercise that determines all the possible paths between two entities and document them as single identifiable pattern, which connect information together. That is, as its essence, what semantic reference data models are about, a solution to overcome the complexity of ontologies by providing to the user identifiable and documentable patterns to be used in their project. In order to achieve this aim, we selected 8 entity types, which are present in many of our datasets: person, artwork, built work, place, group, digital objects, events, and last but not least, bibliographic item. And for each of these entity types, we selected and analyzed a series of standard reference resources used by the community to encode and record information about the entity. In case of person, for example, we consulted Agricol, CCAT, Mark, Via Fuelan, as well as others. In total, we consulted and analyzed 23 different sources. Each of them has been used for one or more entity types. And these sources are fairly distributed across the documented entity types. And as I mentioned before, for each of them, we select a series of elements to describe one characteristic of that entity. Each of these selected elements is then given a definition and mapped to SADOC-CRM, the de facto standard for data integration in the heritage domain. The result is a series of SADOC-CRM patterns for recording basic and complex information about an entity. In order to make everything readable and browsable, we aggregated this pattern by entity type, as we've seen before, as well as by function, making it searchable and easy to use. Let's just see a very basic example. Let's take Ferdinand Odler. We can express information about his name very differently using mark, schema.org, or maybe an XML schema using CCO. Using the reference data model, we use instead SADOC-CRM to distinguish the person, the appellation, and the value given to that appellation. And we construct the pattern, not only in this case, but all cases in a modular way. This allows to express more and more about a specific entity. For example, in this case, the birth date of Adler, or the birthplace. And these modules are independent and interconnected with each other, and that lies the power of it. We can use as many as we want. We can define our own template. For the knowledge graph engineer out there, we provide also turtle encoding of this pattern, so it will be easy to use and implement in each of the systems we prefer. And it's also important to notice that we do not prescribe vocabulary, leaving the choice of formalization of a specific term in a specific language, important, to the user. If we think about expressing the gender of a person, for example, we could use the getty thesaurus, but we could also use a more specialized and updated resource, such as homosaurus. The semantic reference data model distances itself from a schema because we express semantic possibilities. And each of the patterns provided both text and a graphical overview. With this select and extract pattern encoded basic information such as appellation, as well as a more complex one, such as the encoding of a historical city in space and in time. And we develop a very long list of patterns covering a wide amount of information. And these patterns are fairly distributed across the selected entity types. As I mentioned, are open and usable by everyone. They are available on the Swiss Art Research Infrastructure website under the section Documentation. They're easy to find and it's possible to browse them by entity type, or we can even search for them through the search interface on top of the navigation bar. And that's it from our side. These are the websites that you can consult to follow our work, or to check it better, or to actually use it. Thank you very much.